1 parsec is equal to 3.26. 3.26 light year. This is also important information, right? The size of the universe is nearly 10 raised to 10 light years, right? This also another information you have to keep in the mind. Size of the universe. Universe is equal to 10 raised to 10 light years. This approximate value only, but remember that. So today you have studied a astronomical unit. Astronomical unit means that is the distance between center of the sun and the center of the earth, right? So astronomical unit is used for measuring astronomical distance. Distance between heavenly bodies and all. To measure we can use astronomical unit, we can use light year unit, we can also use parsec unit. And the relation between that also you have been given. Okay. Next, some units of length, the smaller units of length. Now we were discussing bigger units of length. Now I am going to discuss smaller units of length. That is 1 micron. 1 micron. 1 micron is also called as 1 micrometer. Micrometer is denoted by mu m. This letter is a Greek letter read as mu m, micrometer. 1 micrometer is also called as micron, is also said as micrometer. It is denoted as mu and m, right? Micrometer, right? 1 micrometer is equal to 10 raised to minus 6 meter. 10 raised to minus 6 meter. Next is 1 nanometer. Nanometer is equal to 10 raised to 1 nanometer. That is equal to nanometer. 1 n smaller. N and smaller. 1 nanometer. That is equal to 10 raised to minus 9 meter. These are you have to remember only. That is why, right? This is very important. I will remember angstrom unit. A-N-G-S-T-R. Angstrom. On angstrom unit. It is noted by 1 A and a 0 mark. A 0 mark on the top of, on the roof of A, on the top of A, you write. Then you will mean this as equal angstrom. A-N-G-S-T-R-O-M. Angstrom unit is equal to 10 raised to minus 10 meter it is. So this is important. Nano is also important, right? 10 raised to minus 10, right? Minus 10 meter it is. Okay. Next one is Fermi. 1 Fermi unit. Fermi unit is FM it is called. 1 Fermi unit. This is equal to 10 raised to minus 15. 10 raised to minus 15 meters it is. So atomic distances to measure we can use Fermi also, and also angstrom also we can use. Sometimes this also we can use, right? Okay. So nanometer, angstrom, micron is also said as equal micrometer, denoted by mu m, right? Micrometer. 1 millimeter, everybody knows. 1 millimeter, mm. 1 millimeter is equal to, every that is equal to 10 raised to minus 3 meter. 10 raised to minus 3 meter. Right? These are some important units of distances, large distances and small distances. Now, units of mass. Units of mass also I shall discuss. So this lesson we are finishing today, right? Not a very important lesson, but only information I am giving you. Yeah, you had to remember all these things, right? 1 metric ton. 1 metric ton is equal to 10 quintals. 1 metric ton is equal to 10 quintals. 10 quintals. That is equal to 10 into 100 kg. That is equal to 1000 kg. Important information. You knew it, still I am just refreshing you. And 1 quintal, everybody knows? 1 quintal is equal to 100 kg. That everybody knows? Next is, right? Now it is I'm coming to a very small unit, that's bigger units, and now I'm coming to a very small unit of mass. Right? Metric ton is a very big unit, right? That is about 1000 kg. Quintal is also a big unit, that is about 100 kg. Next is smaller unit of mass. Smaller unit of mass is AMU. AMU. AMU is denoted as atomic mass unit. Atomic mass unit. Sometimes it is not by simply one U. UU. When I write as one U, it is one atomic mass unit. One atomic mass unit is equal to 1.66 into 1.66 into 10 raised to minus 27 kg. This is what is called one atomic mass unit. Atomic masses, for example, the masses of electron, masses of proton, masses of neutron, etc., are measured in terms of this unit. This is AMU, atomic mass unit, and denoted by simply U. Unit U means atomic mass unit. Am I correct? These are some important units and values that you have to remember so that we can easily apply when you do simple problems, right? Now, one question is marked here. Calculate the number of light years in 1 meter. Number of light years in 1 meter. One question I have marked here. That is the last part of the lesson today, right? So that is also very simple, right? We have to make a relation between meter and how many meters constitute 1 light year. That's the condition. We know that 9.46 into 10 raised to 15 into 10 raised to 15 meter is equal to 1 light year, 1 Ly, right? Therefore, 1 meter is equal to 1 meter is equal to 1 divided by 9.46 into 10 raised to 15 light year. Light year, the notation is simply Ly. This is equal to 1.057 into 10 raised to minus 16 light year, right? The relation between meter and 1 meter is equivalent to 1.057 into 10 raised to minus 16 light years, right? Also, one more question. Mass of an electron is Electron is equal, everybody knows that. Otherwise, you must know it. 9.1 into 10 raised to minus 31 kg. Minus 31 kg. Right? How many electrons will constitute 1 kg? That's the question. How many electrons will constitute 1 kg? Right? How many electrons will constitute 1 kg? Therefore, number of electrons is equal to, that is number of electrons in 1 kg is equal to the total mass divided by mass of an electron, right? Total mass is 1 kg. Divided by mass of an electron is equal to what? 9.1 into 10 raised to minus 31 kg, right? That's equal to, the value you are getting as equal to 1.1 into 10 raised to 30. 1.1 into 10 raised to 30 electrons will constitute 1 kg. So this is lesson about, when we recapitulate the points we have discussed in this lesson, we have started with the physical quantities. What's the physical quantity? Everybody knows that. That means the quantities that we deal in physics are called the physical quantities. All quantities that we deal in physics are measurable quantities. Hence, we can say that all measurable quantities are called physical quantities. Physical quantities are categorized into 2 varieties, which are they are base quantities and derived quantities. Base quantities also called as fundamental quantities. Earlier days, when physics was not so advanced, then we had only 3 fundamental quantities, right? And also units also has 3 units: length, the unit of length, the unit of mass, and unit of time. Time is always second. In all systems of units, time is always second only. When science advanced, then we got 7 in place of 3 fundamentals. We had seven fundamental quantities and two supplementary quantities. What is the fundamental quantities? What is derived quantities? Why the quantities are called derived quantities? Because those quantities which are depending on fundamental quantities for their clarification, those are called derived quantities. Except that of seven fundamentals and two supplementaries, all those quantities that we discuss are derived quantities only. That also very clearly I have explained why it is a derived quantity, how derived quantities are depending on fundamental quantities and all, right? Then system of units we have discussed. It. System of units we have CGS system of units there, MK system of units and SA system of units there. CGS system and CGS system and MK system are old system of units. Because in old system of unit we had only three fundamental quantities. When science advanced, we got many more quantities also. So many fundamental quantities came up. How many are they? Seven. And the units of seven units already explained in a chart. That also you will see their symbols and everything must be studied very well. And also the important question in this topic is that why is SA system more important? Right? SA system, why it is more important? That also has been studied you. It is a decimal system. It is a coherent system, right? And it is a rational system and it is an absolute system. All these things have been explained very well, and also the notes also the photo of that also will be coming to you. Then we discussed so many distances, big distances, how to be measured, light year, astronomical unit, parsec unit, micrometer, then mass units, so small, big, everything we have discussed, right? Tomorrow we will come with another lesson, right? Yeah, dimensions of physical quantities will come to, right? Uh, so this is the lesson about today. Thank you very much, right? Have a very nice day.